FTC team. I'm a member of FTC team 12518, Almond Robotics. First Online is an online forum that we created with other teams to teach each other and to grow together. Today's workshop will be presented by team 14270, Quantum Robotics, an FTC team from Bucharest, Romania. They also won the 2021 Inspire Award and were 2022 MTI semifinalists. If anyone has any questions, there will also be a Q&A in the chat.
Thank you. Hello, I'm Alex from Quantum Robotics, and I'm here with
Tudor from also Quantum Robotics.
Yeah, and today we'll talk to you about the build and design process for your robot and also the time management throughout your team. So first, let's talk a few words about who we are and what we are as a team. So Quantum Robotics was founded in 2017 by 6 Olympiad students at various subjects such as mathematics, informatics, physics, and others as a means to express their passion for robotics because they were searching for something more outside of school. Our team right now consists of 15 members and 5 volunteers, which are all students at the same school, the International Computer High School of Bucharest. And every year we try to recruit new members in order to maintain a team's sustainability and to get new people to become those veterans that are right now and to keep the team going from year to year.
Now I'll say a little bit about FTC and what we're doing. So in FTC, basically every year we get a new team and we have just some months to build our robot, to prototype it, test it, and see what suits the best for this specific team. As you can see in this photo is the robot from last year. This photo is taken at MTI, which is one of the most important competitions of FTC. And yeah, basically FTC, it's just, as you may know, FLLA, it's just a bit bigger and more complex robot, and more complex activities.
So we'll start off by talking about the brainstorming at first. So every season we start with a brainstorming session before actually building a robot. So each member of the technical department presents its ideas and about the robot and what we should do and their game strategy. And then after this, we choose the best one and the best ideas and divide the big hardware team into more smaller sub teams that each have a subsystem they have to build. So each sub team is given a subsystem on the robot that they have to complete first of all in CAD before we finally finish the whole project. And while like teamwork between these sub teams is very important so that everyone can communicate and cooperate well when designing their own subsystem, communication with the other team members is also very important because we have to ensure that every subsystem works perfectly within the whole robot and they cooperate very well with each other. So right here we have a few examples about the brainstorming that we do. As you can see, there are a lot of different members from the whole technical department. So basically everyone, not just the most like the core team of the technical department, but literally everyone that has worked before in technical fields, thinking about what we should do this year, coming up with ideas and making sketches like this one, for example. You see the whole whiteboard here behind is now filled with all sketches and a lot of thoughts about what to do and how to build a robot. So it's always,
sorry.
Yeah, so it's always important to think and consider every idea, not just the ones that seem important. Like even the ideas that seem very bad and seem like they would have massive flaws. It's very important to actually think them all through to the end, because most of the times you might not see it, but the idea like optimize may actually become a very good idea in a very good design.
This is exactly what I wanted to say, because we like to listen to every idea, like everything, even if there is small idea coming to your mind, we like to listen to it, maybe implement something a little bit more different, but we like just to listen to all our teammates, to listen their opinions, and after that just prototyping and testing.
Yeah, this is probably the most important part in the whole design and build process, because You want to make sure you got the right design in mind from the start. Yes, of course, it might not be that way since that's how it works most of the time. You debug and fix stuff after you finish your first version, your first iteration, but you always want to make sure you have the right mindset and the right design that you go over. So next, Tudor can talk about CAD and prototyping.
Yeah, so at the beginning of each season, after the team is presented to us, after the brainstorming session, we just go into our CAD program and start sketching some stuff that we already designed on the board and take it to the next level in 3D model. And after that, we like to see how some prototypes will work with, will interact with some, like for example, this year's cones. We put also that in CAD and see how it works. After that, we like to build our robot in CAD first and do all the subsystems in CAD, and after that prototype them in real life. But it's very important to have a CAD model because if you want to see, like, I don't know, maybe you want to integrate a new part in your robot and you have just a little small some millimeters to work with, it's really important to have that model always open for you to see what can we add, what can we modify, and at the end just have like the perfect robot in CAD, and after just building it in real life. When the
Yeah,
robot
also,
sorry.
sorry. Also, I see a question in chat about how often do we have meetings and how long we stay for each meeting. So our like program is actually very different from what most teams do. We don't really have fixed meeting times or fixed lengths of those meetings. Basically, we have an open door policy in our workshop, which means that you can come to we can come and work for as long as you want and whenever you want, as long as you come and work. So basically, if you want to like take a break, if you feel like you're just not feeling it that day, you don't want to work today, you're very tired, you're stressed, you have other things to do, or something comes up, that's not an issue. You can just take the day off. But if you have some like I don't know, like 1 or 2 hours to fill and you want to work, you can just come to the workshop and work as much as you want, basically. So I'd say that it can grow from like meeting once a week if all of us have like a full week to maybe like every day a week, like 5 days a week, which is what we mostly do now. And the times can vary from like 1 or 2 hours if all of us have something programmed to like the whole day, spending like 8 hours in the lab. So it's actually uh, there's a very big variety between those times, and I'd say on average we spend around like 20 to 30 hours a week. Now, Tudor, I think you can continue with the cat.
Yes, so after we build our robot in CAD, that's just what I said, we start prototyping the whole robot, build it in real life with what we have, see how it will work, and after that, after we see how it works completed, we modify some things. For example, we need the intake to be faster. We go back to the CAD model, we modify some things, see how we'll, I don't know, maybe another teammate has an idea of how it'll be faster. We try to implement it, test it, and after that, do the final modifications in CAD and rebuild the subsystem. I think it's, yeah, you can see some examples here. First of all, we tested in real life with some small examples. This is a miniature version. After that, we designed how it will look, and at the end, the CAD model finished. So yeah, first of all, you need just a prototype to see how things will work, have a brief idea of how you need to build it, and after that, take it to the next level in 3D modeling.
Yeah, and also one very important thing is that you want to be able to print like smaller versions of your subsystems. Like for example, for this team shipping element that we had last year, our initial version, see this took like, I don't know, maybe 15, 20 minutes to print, and it was a very fast assembly of the whole system here with some Go parts. Like this is a very fast and efficient prototype, and it shows like the perfect coordination between CAD modeling and prototyping with Go and pre-building. So This is what we try to achieve all the time when we're prototyping. We have like the whole CAD model almost done, or if we're like halfway done and want to see if something will work or not, we just print a miniature version or print a smaller, easier to manufacture version that we can test quicker. So further on, we're gonna be talking about exactly what Peter said, testing and improving. So basically, after you assemble your whole robot, like after the CAD is done, you have you can assemble everything very quickly. So after the whole like model is finished, like down to the smallest washer and shim, you can assemble everything over a weekend if you try hard enough. That's what we mostly push for before competitions. We actually finish our CAD model very late, like a week and a half before the competition, and we just spend a weekend assembling it because it doesn't take that much since everything is just like a big Lego set. And so we have like exactly 1 week to do what I'm going to talk about here, which is testing and improving your own robot, basically debugging everything. So after your robot is assembled, you put it on the field and see how everything works and coordinates with everything, like the subsystems bond and whatever. So this allows you to see exactly what you couldn't see in CAD or simulate before, which is how the synergy between those subsystems work. And in order to make everything work faster, each sub team like focuses on its mechanism to see what the flaws are. And one thing that we always do, and that's very useful to us, and we see it's pretty uncommon to our teams, is that ironically enough, even though it sounds like a gimmick, we use slow motion footage a lot when we test our intakes, for example. That's the first use case that I find. So when you're testing a subsystem like the intake, where everything just like shuffles out and all the game elements hit whatever when you have small game minimums like last year. You cannot really see in real time what hits where and what bounces off which wall and whatever. So why it bounces off weird or why it doesn't work and why it funnels weird funnily. So what you want to do is you want to take like very high frame rate slow-mo videos so that you can see exactly what's between the element and the subsystem you want to get it in, like the outtake or whatever. So that helps you a lot in seeing what doesn't work well within the subsystem when it's going at a very high speed. Also, after we have everything done, and even before, um, we set very tight deadlines to have enough time to coordinate with driver practice while still fixing a robot, because driver practice is a very important matter, as you know, after you have your robot done. And we want to make sure we have enough of time to actually practice with the robot, even though we're still fixing stuff and improving it continuously. So mostly we just have very strict deadlines so that we can have everything done by a certain hour or day so that we can focus some time for specifically driver practice and not actually touching or modifying the robot itself. As you can see here, these are a few examples of us testing our subsystems. Here we actually recorded so much slow-mo footage of this design on the right here, this intake, our second iteration of the intake, because it was a very complex design that was hard to fine-tune and get working well. And because of this, like tubes kept hitting a certain latch that would basically break the intake, and we had to like cut it down to the millimeter, those silicone tubings, and arrange them to a perfect size to see that everything fits, which is exactly where slow-mo footage came into play. We had to see which tube hits what, uh, when the actual hitting happens, when is it too much, if it's the speed that's wrong, or if it's the placement, and so on. And also running practice matches is a very important thing, but you want to make sure you do it well. Like you don't want to just practice and practice and practice until you get a better score. You actually want to maybe record all your matches, which is what we did in a certain period of time, and then count your scores both in auto, tally up, and endgame, and divide them, and then compare what went wrong in every single time. Like what we do mostly is that when we're practicing and when we're doing just practice cycles, not necessarily matches, is that, you know, like when you're doing like laps when you're running and you have a certain stopwatch, and you set laps for each lap, you time your lap, you know, and you want to go faster for each lap. We do this with every cycle. So whenever we're cycling and practicing, we start a stopwatch and then we set a lap for each cycle, and then somebody is just like holding the stopwatch and keeps counting the seconds and yells the time for like each cycle. And we keep trying to push forward until it gets lower, just like with athletes keeping trying to keep for push for lower times when running. We do the same thing when driving with cycles. That's like one very neat thing that we did. Tudor, if you can maybe go over this
Yeah.
one.
So as you can see, this is our timeline. First of all, the first week after the team is given, the first week we just do brainstorming and team organizing. Like for example, me and Alex this year were on the chassis, and some other members were on the other subsystems. After that, 2 weeks from when the team was given, we like to start CADing and prototyping. First thing first, we like to CAD, like get some small parts printed to see how the index should look like. After that, we test it, see what can be improved, how fast it need to be, how we're going to mount it, and everything like that. And testing and improving the last 2 weeks. After that, we like to do some practice, as Alex said. But in this testing and improvement part, we like to test everything that works together. Like, for example, as Alex said, if the intakes doesn't work with the outtake, we need something to fix that. And this is the improving part. So we really like to have like, I don't know, maybe a tight timeline, but we find it is the most effective one, because you need to have a specific deadline for each subsystem to be able to be organized and have a successful robot. And after that, we just do, after testing and improving, we just do driver's practice, programming the autonomous, and just try to be better at driving and see what can be, see what the robot can be and push the limits of the robot.
Yeah, so one thing that I feel like sets us apart with other than very other teams is that the fact that most teams share like a very similar process, except that they have CAD and prototype switched up so that they first free build stuff and prototype it to see if the idea is right, and then they move on to CADing the actual thing. While we prefer, first of all, CADing the idea really fast, like a bare bones CAD, to have a more quality prototype so that you can see if the idea optimized would actually work. And also, this like whole process can be applied in a very efficient manner if you have a lot of members. Like for example, last team, we had like 6 people on our technical team, which helped us a lot when we had our regional and national competitions. Like they were about 3 weeks apart, and not a lot of people know that we did this. But before our national competition, we actually rebuilt our whole robot from the regional competition. Like we switched the whole idea, we flipped it upside. So the way we did this is that you see this whole design cycle basically lasts here like 6 weeks, but we only had about 3 weeks. So what we did is that those 2 weeks that we're supposed to be testing and improving, we split our 6-man team between 2 different teams. One that will work and improve on the regional robot and keep debugging and making sure everything works. And the other 3 that were starting already to CAD and assemble and prototype the new robot, basically the rebuild. So that's the way we managed to power through and come with a whole new different robot in just 3 weeks. Because it actually wasn't just 3 weeks, it was 5 weeks. So it's still like a good way. It's a very good use of this design process. If you have a lot of members, you want to make sure that you can like organize your members in the right departments, in the right subsystems to make sure that everything can go well. And you want to make use of all those extra people that maybe don't seem that useful when you have like 3 subsystems and 8 people, but when you split up your process like this, you can actually test out multiple ideas and develop multiple things in parallel and make things work faster than they would normally. Now, of course, the FTC isn't just about building robots. So we have a time management plan about event organizing as well. So what we found that it's very uh, that costs us a lot of time is actually thinking the ideas for an event. And especially during the season, when you're caught up with a lot of stuff to do and you're very busy normally, you don't really have that much time to be creative and develop your ideas about all these events. So the time in which we come up with all those events is actually in the summer, in the off season, which we make a list with all the events we want to organize. And then from our PR and marketing department, we choose one member per each event that we're basically like that is basically in charge of the event, thus making him or her the event organizer. So everyone is like in charge of his own like event, much like how the harbor department is in charge of his own subsystem. So even if the members have different events, the department works together and tries to organize the whole event together when it gets close and when the need for more people to work is needed. But yeah, as I talked about, I want to emphasize on the fact that most of the work and the idea and the planning and everything is done in the summer, so that we have the time in the season just for stuff that it's like really urgent to do or stuff that has to be done right before the event, so that we can like take a lot of work off our shoulders during the season when there's already so much stuff to do. And yeah, here we have a few pictures of our like events, or successful events in the past. Tutor, if you can like walk us through our communication apps and
Yeah, sure. So one of the most important things in a FTC team is the communication, because every member that works on that robot needs to know what is going on. So for example, if Alex changes this evening something at the robot, me or another member should know what he changed, so we can see if that change our, I know, if I want to build something else and that what Alex changed maybe affects mine, we need to talk about it and see how it's going. So we use Trello and try to organize everything. For example, a deadline, who is working where, and I mean, what should we do. After that, we use Slack, which is the main communication app. So every day we text there. We have different channels about, like, for example, one channel for hardware, one channel for PR and marketing, and everything that needs to be discussed there, we discuss in the specific channel. And our table, where we write everything that we have done in one day. For example, if the dailies that we need to write, and all somebody that didn't come that day know what the other people done. So yeah, I just said communication is really important, and if you have like a very good chemistry between you guys and you are really good friends, you'll see that the team will improve a lot faster, and you guys will communicate a lot and have a more successful robot. This picture, as you can see, is from Trello. Future projects, we need to separate our things. And as you can see, that little icon down there where field elements bags, that those are the people that are working on the project. And yeah, we like to be organized, so we just do some I don't know, some splitting between those activities.
yeah, and also you can see the tablets here. The title in the middle is Sprint Zero. So basically, we like to call all of like our competition sprints, like sprints of work. So this is the first sprint, like the very early beginning of season sprint, where you try to get your robot done as fast as possible so that you can test everything and see if your design has been correct, how other robots are going, and so on and so forth. But we like to call all these sprints because what you're doing is that you're not really trying to run the long run with everything. With your tasks and with your buildings, you want to keep everything down to little sprints. So instead of like thinking of the whole building a robot task as something very long and something that you keep working on and working on and working on until it's done, you want to split everything between smaller sprints. Like for example, you want to keep, instead of just saying, I have a week to build the outtake or whatever, you could say, I have like a week to design the parts, like a day that to design the part that keep the sliders on the chassis, a day to decide what slides to use, a day to design our like arm or whatever, a day to design a gripper, and so on. You know, you want to split everything in like smaller chunks of work that can be achieved very fast. So now, if you have any questions, we would be very happy to answer them. And also, if you maybe want to share a little bit about your design process, and we can go over different ideas and whatever you feel like would be improving.
Hi, Alex, the tutor. Thanks for the excellent presentation. It's very informative and helpful. I have a couple of questions. Maybe I can lead the way, and then the other people can think about what they want to ask you about. And I think maybe the first, I think in recent years, like Romania teams did really well at the World and MTI. And could you give us a little idea, what is the organization of FTC look like in Romania?
Yeah, so it's actually pretty simple, but the one thing that's very different from other regions is that much like Chesapeake, we have our state competition, like our national competition, very far in the season. Like we had it like maybe 3 weeks before Worlds. And also our regional competitions are very late in the season as well. So one thing that I feel like sets the teams apart from other international teams is that they have a lot of time to like sit and make sure everything is well and calculated. So they have a couple of good months before they have to present with a robot at a competition. Like they're allowed to spend like 2 months just on CADing and making sure everything is down to the last millimeter correct and everything. But also they have a lot of time to reiterate and build different robots and different ideas and see what works best. Like I feel like the one thing that's very nice with Romania is that we're given a lot of time to work on our robots before we actually have a competition, instead of stressing us with league meets and competitions early in the season.
So how many teams in Romania?
Yeah, we're quite a big region. We have around 170 active teams last season. And right now, we still don't know the actual number, but I feel like more teams are signing up as we speak. So,
Sounds great. Yeah, so you mentioned about that you guys use the slow motions to kind of debug and learn the features that you're trying to implement it. Could you share a little bit of like what kind of systems do you use, and what is the software tool that you try to use the slow motion help diagnostics and experience with it?
yeah, sure. So if I go over this picture right here, I'm not sure if it's visible, but this was one of our like very um, challenging designs for our intake. So what we wanted to do is to make sure we only collect one piece of freight. Last year, we had a little switch here, right after this little piece of tubing at the front, that would get knocked over by the first piece of freight that enters the intake, and then basically put a wall between all the next pieces of freight that would enter, so that only one can go through. And this was very problematic when we first assembled it, because as you can see, and as you may know, the tubes, when they hit each other, they like flap around a lot. And so a lot of the times they would actually end up hitting the switch themselves. So here we use a lot of slow motion, and it's just very basic stuff. It's just the normal slow motion that you have on your phone, like in the camera app. It's not like there's no crazy software or whatever. So we just like to film a lot of slow motion, because when you just run a motor through this, you don't really see what tube hits the switch or what happens. You just see the switch sitting down, and then the next second it's up. So the slow motion helped us really see what tubes were hitting it and why, because I remember we cut down all our tubes like to a very small size and it was still getting split. And then after we viewed the footage, the thing was that the tubes were hitting each other and were making themselves go left and right. And that was what was making them hit the actual switch. So then we were really thinking about how to align our tubes, how to make them maybe more rigid so that they would bounce around less. And it really helps you like see what's actually happening rather than just knowing what the result is.
I see. Yeah, I think others, if you have questions, feel free to unmute yourself. And maybe while waiting for that, I think you mentioned about that your teams at the beginning of the seasons that you would divide it into sub teams, and then you like entrust them to do their work. But in the end, you do need to put back into the system. So how do you kind of integrate those subsystems that you make sure like they're not like go too far on the road, and then it's hard to incorporate into the one system?
Yeah, so basically I'd say that one thing that really helps keep us in place is that every week we like sit down and talk for like about an hour with our mentors also about what we've done. Like every team shares its own work, like we share how far we've got, our progress between each system, and then we really sit and think about how it all works together. Even though like while working, whenever you're making like a massive change, you always use like the Slack channels for your technical department, like for hardware or whatever. You always like when you basically want to make like a big arm or whatever that takes a lot of space, or something that has a very optimistic movement, you always share your idea and are like, hey, I'm thinking about doing this, but maybe that would limit our intake freedom to this. And are you guys okay with that? Can you do this? Is this achievable? Maybe the intake needs more space and I should change my outtake for that. And I feel like communication really is key here, that whenever you're like making work that's not really massive or changing the other subsystems in a big way, like wherever you're maybe just adjusting the gearing on your slides, or maybe just redesigning the gearbox, but still keeping a similar overall shape. It's not really that important that everyone knows, so you can just focus within your sub team. But when you're making big changes, you always want to like talk to everyone about it. And then like weekly, we get around for a big meeting to make sure that everything goes smoothly together and we don't have issues when assembling everything together.
I see. So another area I think you touch on is very important is that to setting timelines, and I think normally is not a difficult to to know what the timelines are, like the competition date, but I think it's often have to our teams is like they're always tweaking the robots, right? Like and then they don't have enough time for practice. So the question is that I think that maybe two questions here. Like one is, how do you enforce the timelines? And the other is like how much time you have to leave for practice.
Yeah, so we always try to like go over this 6-week rule whenever we're designing a robot or upgrading a robot. So we take like 6 weeks as a chunk before the competition to go to this whole operation, or maybe we can cut off the brainstorming part like this 1 week, and we can cut the process down to like maybe 4 or 5 weeks. But we always try to leave those 2 weeks like alone. We always want to have everything assembled and basically like drivable until the last 2 weeks, because the last 2 weeks should always be like reserved for just driving and debugging. Like you're driving, you're running practice matches, you're running cycles, and you want to see like in those 2 weeks why your intake is going slower. Because yeah, if you keep just fixing your intake, or you're not really done with assembling it, or you keep just changing the design or whatever, you're not gonna have time to optimize it and to like really get down to small things that make it slightly slower. Because if you think about it, like if you average around 10 cycles in a match and your intake makes you like go slower for like half a second each cycle, that's basically like 5 seconds that you lose overall in a Telia period, which means like one whole cycle. So it's really important to like calculate those small timings and to know that everything matters, like down to like a third of a second, half a second, and whatever. Like every little time is crucial when you're running a lot of cycles.
I see.
And I will also add here that, for example, if somebody from a subsystem, I don't know, maybe feels sick and cannot continue his work in these 3 weeks of assembling and prototyping, because our communication is really strong with each other, a different person from a different subsystem can join in and continue his work, because like he shared already his idea and the other person knows how to continue. And this is also really important, because if it's an emergency and he cannot continue and he needs just to have some weeks of rest or something like that, another person can jump in and finish his work. So yeah, this is also really important in communication.
Yeah, and I feel like a good example with those timings that I talked about would be like last year when we tried to push our autonomous to do 7+1 cycles in autonomous, was that like if you have the more cycles you have, the more those little timings matter. Like the one thing that pushed us from 6+1 to 7+1 was actually just cutting like 0.1 of a second, like 0.1 of each sleep that we had between waiting the robot to reach the warehouse or like waiting it to extend its sliders. So that's again where we used a lot of slow-mo footage, because when you slow everything down compared to real time, you can actually see where the robot is just sitting and not doing anything. So because in real time, you see the robot drop a cube and then just leave. But in slow motion, you would see just drop the cube and then wait for it to fall. So you can just cut down the sleep before dropping it and waiting a little bit to fall. So you can just drop it and know the exact second where to cut the sleep and have it just run back to collect it to start another cycle. So that's just like, it may seem just like a 0.1 of a second, but when you're running 6 cycles, it's a whole second. So it's very important to like actually cut down on the smallest of sleeps because they can add up to a whole cycle.
Yeah, that's actually a very helpful tip. That was great. Like you sharing that detail with us. And so do you guys still keep your writing engineering notebook?
Yeah, we do, but we try to use our engineering notebook as a mean to let the new members learn. So because the engineering portfolio is usually the most important one, we kind of let the freshmen, like the freshman team in our PR department, handle the engineering notebook like as a major part, with the like seniors and juniors and the like veterans just supervise them. Because in the engineering notebook, because you have so much actual like design to do and so like such a big chunk of work compared to the engineering portfolio, it's like the perfect amount for freshmen to like get start working a lot and actually get stuff done and just keep working and working until they get it doing like they get better. It's like enough work to actually improve while you're doing like one big task instead of just maybe like a small part of the engineering portfolio where let's say you're not really good at doing it, but after you finish it, you've improved, but you don't really have a lot of room to practice and move.
I see. So can you describe a little bit what is your process to convert the information that you have in your Trello and engineering notebook into the portfolio, like which is like 16 pages now?
Yeah, well, we have like a few pages in which we describe our events. We like have a small section for each event. We have a small paragraph containing the most important data. And then we have a few pages for like each subsystem gets his own page, or maybe two subsystems are split into one page if they're like smaller or less important subsystems, where we try to like get the essential descriptions of everything and the process and basically just like a big summary of the key things that we learned through making those subsystems.
I see. So how's your mentors that play a role into your process?
Yeah, so we are a student-led team mostly, which means that us, the students, get to make the crucial decisions in mostly everything.
Mm,
The mentors are mostly just supervising us and trying to guide us into the right decisions. But in the end, everything that we decide on, everything that we think about is like purely us. And also the mentors help us a lot with the legal stuff and all the legal data about purchasing stuff, keeping a NGO and everything, so that orders are easier to make. And also, mentors like come to this weekly, like the one weekly meeting that I talked about, where we present a robot and just like give small tips
mhm.
and maybe like ask us questions about how are we gonna solve this, or maybe they point out things that we haven't seen, or just try to come with like perspectives that are outside of the people that actually worked on the robot and are already like thinking inside the box.
I see. So do you guys have some challenges in your design or maybe time management processes that like reoccurring, like always happen, like every season is kind of you have to work on it. Do you have those type of challenges? And how you guys like address those challenges?
Yeah, so of course we always get those problems. So I think the most common one would be that we're not done on time with the assembling and everything. Or even if we are, like the one big flaw that we have is that we keep redoing stuff and changing stuff until we don't really have enough time to practice or test everything well. So in this testing and improving part, I feel like what we do the most, and it's a bit of an issue, is that we always try to like see that something isn't really working well and we try to change it and then we change it again and so on, instead of just maybe having something that works stably. But in the end, it's important that you like have everything well thought out from the start. So I feel like the one way we could fix this better, if we would maybe dedicate more time in the prototyping part after we CAD everything, to make sure that the idea is good from the get-go and we're not just wasting time CADing and building something that isn't really optimal.
Mm, great. I wonder if there's any other questions or maybe do you guys have some additional thought?
Um, well, I think we've mostly said what we were trying to achieve in this presentation.
Mhm.
And yeah, we like presented what we tried to like our strategy when we were approaching like every competition, from a regional or like a first league meet or whatever to big competitions such as Worlds or MTI, and how we're trying to like transition this process into everything. So
That's great. Yeah. Yeah, thanks again for sharing your experience with us,
thank you.
especially some like really interesting details that that we had been wondering how how you guys did so well and consistently perform well. So yeah, thanks for that, and I wish you the good luck for the good season, and
Thank
probably
you.
hope I see you at some competitions hopefully.
Yeah, hopefully.
Okay.
Thank
Okay.
you, and good
Yeah.
luck to you as well.
Yeah. Thanks everybody for joining us today. Okay. Have a good weekend. Bye.